Good morning to everybody. My name is Diana Marcela Aragon. I am full professor of the Universidad Nacional de Colombia in Bogotá, Colombia. Today, I'm going to talk to you about the development of a self-nanoemulsifying drug delivery system to improve the hypoglycemic activity of Passiflora ligularis leaf extract. Passiflora ligularis is a plant native to American continent. This species grows from Mexico to Argentina and is popularly known as granadilla, granada china, maracuya 12, or Passiflora 12. In folk medicine, their leaves are used to treat mumps, relieve bruises, control infections, alleviate back pain, and antidiarrheal, among others. Furthermore, pharmacological studies indicate that Passiflora ligularis leaves have a wide variety of therapeutic activities, including antioxidant, antibacterial, and hypoglycemic properties. Specifically, the aqueous extract and the ethanolic fraction of Passiflora ligularis leaves have demonstrated a potential secretagogue effect and a mimetic action of the insulin. This pharmacological activity has been attributed to glycoside flavonoids, mainly derived from quercetin, camphorol, or crysine. However, the low bioavailability of these compounds limit their pharmacological response in vivo assays. For the other hand, in the last few years, self-emulsifying drug delivery systems have been widely used as strategies to improve the oral bioavailability of poorly soluble drugs in water, including herbal products or their phytoconstituents. This type of lipid-based formulation, made up of an isotropic mixture of oil, surfactant, and co-surfactant or co-solvent, for an homogeneous and thermodynamically stable nanoemulsions when they are in contact with the gastric fluids. Compared to other types of lipid-based delivery system, the self-emulsified drug delivery system presents several advantages, since they protect the drug or the active ingredient from the gastrointestinal environment, inhibit P-glycoprotein-mediated drug efflux, and first-pass gut metabolism. They also increase permeability and lymphatic transport and have better control over drug plasma concentration profiles, enhancing drug loading efficiency and stability. For this reason, we tried to study the development of a self-emulsified delivery system to improve the pharmacological activity of the extract of the leaves of Passiflora ligularis. First of all, for the solubility evaluation, there was selected different oils composed by of short-chain triglycerides like laurafag, PG, medium-chain triglycerides like cholesterol MCT 70, and long-chain triglycerides like castor oil. After this assay, castor oil was identified as the oil with the highest solubility of the drug within of the phases evaluated. For this reason, this oil was used for further study. It has been reported that the castor oil has been used for the self-emulsifying delivery system design to incorporate other flavonoids such as quercetin, spiritin, and diacetyl. Concerning to the surfactants, these have a function decreasing the interfacial tension to improve the dispersion process of the nanodroplets. Non-ionic surfactants are more used than the ionic ones. Generally, the non-ionic surfactants most employed are the polysorbates with HLB values higher than 12. Cremophor-EL, Cremophor-ELP, and Twin 80 were selected for solubility assay. Twin 80 showed the best solubility of the flavonoids in the extract. Nevertheless, the mix between castor oil and Twin 80 and the co-solvent generating a milky white emulsion. Since surface selection was based in emulsification efficiency, the Cremophor EL was selected and used in the further formulation development. Regarding to the co-solvents, this allows increasing the elasticity of interfacial film between dispersed drops and the external phase formed by surfactant. On this basis, transglycol P and propylene glycol and lutrol 400 were selected for the test. As the result, propylene glycol showed the higher solubility capacity of the drugs and its main compounds, and it was selected for final formulation. In this study, a box-packing experimental design was employed in order to determine the effect of the oil, surfactant, co-solvent, and a silicon polymer effect on the droplet side, PDI, and setup potential of the self-emulsifying delivery system. However, only the droplet side was considered for optimizing the formulation since this property influenced the lipolysis process as well as the rate and extent of drug release and its absorption. The response surface methodology was employed to determine the composition of the self-emulsified delivery system with the lowest droplet size. Statistical analysis yielding a final condition for optimal formulation with castor oil, Cremophor EL, propylene glycol, the polymer of siloxane, in proportions 31 to 120 to 80 to 30% ratio. And the predicted value of the droplet size was 10 nanometers. The prediction of the model was verified experimentally, and the 3 replicates of the self-emulsified delivery system were prepared under optimal conditions. Regarding to the pharmacological activity, in this graphic, we can see the glucose tolerance curve of the self-emulsified delivery system in mice. As it shows, at 30 minutes after the oral glucose, the self-emulsifying delivery system shows significantly decrease of the blood glucose levels compared to the vehicle and compared to the Passiflora ligularis unformulated extract. Likewise, according to the area under the curve analysis of the blood glucose levels, mice treated with the extract and with the formulation decreased the total blood glucose levels by 15 and 28% respectively. We want to thank for the funding of this project to the Ministry of Science of Colombia for the fellowship for the students involved in this project, and also for the Nacional of Colombia for the facilities. Thank you very much for your attention.